Welcome back my dear friends and participants for this course multi-criteria decision making under the MOOC NPTEL series. And as you know, my good name is Raghunandan Sengupta from the IME department at IIT Kanpur. So, we are in the phase of discussing the concepts of multi-criteria decision making, and the broad umbrella which we will continue for few more lectures is basically concept of utility theory, concept of safety first principles, stochastic dominance. And this is the 15th lecture, where the coverage is in general. We have considered certainty equivalent and we have considered two different examples. We will further on go into the utilization of certainty equivalent, why, what is the use, and if you remember there were 2 points. One was basically to understand how utility functions or utility concepts can be used for ranking, and also to find out the so called functional form of the utility function, considering that the person can take a decision, but you as an academician want to find out what type of utility function and which class of utility function the person has, or if the parameters are to be found out. Then we will go into the concept of geometric mean methods and how geometric mean methods can be utilized for different sort of ranking, and later on obviously we will cover safety first, stochastic dominance, hyperbolic absolute risk aversion properties, but these are as we proceed. So, hopefully we will be able to cover the certainty equivalent and geometric mean models in this 15th lecture out of the 61. So, if you see this graph, and this is where certainty equivalent concept and gamble will be utilized to understand what type of person he or she is. So, whether the person wants to take risk, one is indifferent of taking the risk and is basically trying to avoid risk. So, first let us specify what we are drawing and why this diagram is here. I will use different colors to denote. The first is that we will denote the values of the wealth, which we will denote by A, B, A1, B1, A2, B2 along the x axis as noted, and we will denote the certainty value which is given by C. If you remember, we have used that symbol C being denoted on the y axis. So, the values again on the x axis as I am marking, putting a single tick mark, and certainty value along the y axis where I am putting a double tick mark. Now, what we do and how we proceed. So, we consider a 45 degrees line as given. So, why this 45 degrees line? So, this we should at least mention this angle is 45 degrees, and why you will understand. Now, consider on one table, table 1, which I mark by 1, we place wealth of amount A and B, which are different amounts as given here along the x axis, and we consider intrinsically from our side, as we are doing the experiment, we consider the utility function is linear, which means the utility function which we are going to consider for our comparison is u w is equal to w, and the wealths we place A and B, the outcomes are based on the fact when you toss a coin, you get probability half and half, it is an unbiased coin. So, if I consider the overall expected value for A and B, so I will denote by E only. So, consider E is case basically, or I will put the expected value for A and B will come out to be, the utility for A would be A because the utility function is linear. So, it will be A, this star sign is multiplication sign multiplied by half, because half is the probability of getting a head, considering A comes out for a head and B comes out for a tail. So, it will be multiplied by half. So, the value would be A plus B by 2. Now, what we do is that I am using the black color such that the consistency of the notation and there is no confusion. So, A plus B by half would be a middle point, we draw a straight line. So, and if you remember, I have mentioned that we place A plus B on table 1. On table 2, there are no values and the person comes and we ask him or her that this is a gamble with A, B coming out with probability half, B coming out to be probability half, and what will make you indifferent. Or say for example, we place C on table 2 to make things much more explicit and simple. C value is placed. So, the person comes and we ask that what will he take or she take, the gamble with A, B or the certainty value with a probability 1, which is C. If the person says the value of C which has been placed on the table 2, if he or she agrees, which means the point based on which we have found out this would be C, because we have formulated the C value such that A plus B by 2 is equal to C, this is the midpoint. So, the point would definitely be the point which is marked by this black dot would definitely be on the 45-degree straight line. Now, in case the person says no, he or she will not be able to take the gamble, but will go for a certainty value higher. So, obviously, in that case the C value which will be told by him or her with respect to the C value which is there on the table, the person says the C value is higher. So, obviously, the x value which is A plus B by 2 remains same, the C value is higher. So, consider the C value according to him or her is here. So, we note it down and we note down this point, the second point here. So, let me mark it with the red. So, this is the point. This one. And in case, so I should mark with green because the green line is there. Just wait 1 minute. So, the person says green. So, this is the point. If the person says no, he or she would be sure to take that gamble with respect to a certainty value which is lower than C. C already placed. Then the person's corresponding C based on which he is proceeding, he or she is proceeding would be below. So, we will denote the higher. So, consider C is which is kept on the table, again I am mentioning, and the person 1 who comes, he or she says that the C value is above, which is on the green point, and we will denote it by C with a green color. This is C. So, which means this is C, and actually values which I have placed on the table was C, the black color, and for the second person the C value would be here, which is red color. So, I am not using any suffix, I am just differentiating with the color, so that it is easy for us to communicate. Now, what we do is that we change, once we know whether the person value C green is above or C red is below or C black one is on the line, we change the values of A and B. So, consider A and B are changed. So, here is, say for example, new value is A 1, new value of B is B 1, probability remains half half, the midpoint is now here. Again the values are, as I mentioned, A 1, B 1 and a value of black mark is C, for example, C1, where C1 is equal to A1 plus B1 by 2, and this C was, if you remember, we have mentioned is A plus B by 2. So, again the person is asked, he or she says, no, the C1 value which is given does not satisfy him or her. So, C1 value for him or her which they say is higher. So, this is C1. So, this would be C1, or else it can be below, this is C1, which means this is C1 or this is C1. And the third case can be where the person agrees with the C1 and is indifferent. So, this would be C1. So, C1, but with different colors denoting different values, but C1 is the symbol which I am using for the second case. Now, I keep repeating this question. So, I change A1 B1 to A2 B2, same probabilities, I put a C2, C2 is basically A2 plus B2 by 2. The person can give the answer as the value is exactly matches. So, which is indifferent along the straight 45 degrees line. So, it will be C2, color is different, again I am mentioning variable concept is C2, but color different means different values, or else it can be lower, which is red C2, and if it is higher, it will be green C2. Similarly, for the case again I change A and B, this is A3 B3, there is a C3 which is half of A3 plus B3 by 2, and correspondingly the person gives the answer accordingly, which is it can be C3 above the 45 degrees line, C3 along the 45 degrees line, and C3 below. So, what you see as we keep asking the question, change values of A and B and also corresponding values C, you can have 3 different types of profile. Profile 1 would be along the 45 degrees line, which we have drawn, which means the person is based on A and B and C value, A, B and C changing with suffixes 1, then 2, then 3, which means the person is indifferent based on the gamble and the certainty value which is being placed. Because the rate of increase is increasing, but at a constant rate, if you remember the 3 graphs. For the case when the person is risk averse or risk lover, the profile for the person who is risk averse would be increasing but at decreasing rate, which is the green curve, and for the person who wants to take the risk is increasing at an increased rate, which is the red curve. So, these are the curves which we had considered, the marginal utilities. So, in this way certainty value can be utilized, considering that we very simply do the experiment. Now, what I said is exactly mentioned here in this slide. So, A and B are wells, as we have discussed, A and B are wells, and we consider the utility function to be W, hence the straight line 45 degrees line. You form a lottery that has an outcome of A with probability half, as already mentioned, B with the probability half, then obviously the utility which I will only denote by U would be A plus B by 2, A plus B by 2. Now, we place C exactly equal to the half of A plus B by 2, as we have mentioned. You keep changing the values on A, B and ask the investor how much certainty value will make him or her take that gamble. So, again over the 45 degrees line, below the 45 degrees line or along the 45 degrees line. So, the expected value of the lottery is, which I have mentioned time and again, is A plus B by 2, which is equal to C. The risk averse, risk neutral and risk seeking person would prefer C, would be based on the concept, would basically take the decisions accordingly. If he or she, risk averse person, would prefer a higher value of C, would be indifferent between C and A plus B by 2, the value which you are given, and would prefer a value which is lower. Depending on that, the person profile would be a straight line which is increasing at a constant rate, curved, the green one which is increasing at a decreasing rate, and the red one is increasing at an increasing rate. Plot the values of C as you vary A and B, and this variation of C for the answer which he or she is given, that means the red colored C or the green colored C or the blue colored C, the value of C which you are putting is fixed, but his answer or her answer is basically what you are trying to plot. A risk neutral seeking an averse person would have, as I mentioned, the part, if it is a neutral straight line, again I am mentioning, if the person is risk averse, the curve which is green above and slowly sloping down, and for a risk seeking person would be below and sloping up. Now, how can we use the concept of C, which is certainty value, further on to find out an explicit form of the utility function? Suppose you know that the actual form of the utility function, form you know, but exact parameters you do not know. The form which you know, I will just highlight, is an exponential part with A values, parameters not known. So, you will ask the person who has, which you think, or you are doing an experiment where the utility function should be exponential, and you ask that person, you give a lottery with a 50-50 chance, probably half and half, an unbiased coin being tossed, and the values of winning 50 with 50% probability is 10 lakhs and another 50% winning is 1 lakh. Now, you place that and ask that person what is the amount he or she is going to pay to buy that lottery. So, obviously, somebody has to buy, and consider the person says, okay, I am willing to pay 4 lakhs. So, 4 lakhs means that he or she is trying to balance the expected value of the lottery with the value of 4 lakhs, because in that case the person would exactly understand that the amount of 4 lakhs I am paying to buy, in the long run, if he wins any two amounts, either 10 lakhs or 1 lakh, the overall expected return would be 4 lakhs. So, in that case, for the certainty value, the overall expected value of the utility would be this, which is because I put W, which is 4 lakhs, into the equation, A value is not known and the probability is 1, because he or she has already purchased, and the corresponding side for the lottery would be the utility for 10 lakhs is what I am underlying with the a little bit darkish yellow color, and obviously multiplied by half, and for the value which the outcome is 1 lakh, this is the expected value, where A value is again unknown and this is the probability. So, you put this equation, do some iterative methods and try to solve and find out the values of A. So, this concept which I used can be extrapolated for any other utility functions, and the parameters can be estimated, not found out exactly. Now, few concepts. For every gamble, there is a certainty equivalent such that a person would be indifferent. So, obviously, we saw from the experiment that if C is the value or the certainty value, then a gamble, whatever the value is, A, B, X, Y, there would be a certainty value for which the person would definitely be indifferent between the gamble and the certainty value, which means that if I draw the diagram and I denote the certainty value with the blue color, which I have drawn, but I will still mention it again. This is the blue color, probability is 1, I am marking it here, and if I consider the certainty value of C, then the corresponding utility would be UC, utility function is given whatever form is, and that would be equivalent. Consider the gamble has two outcomes, it can be 3, 4, so on and so forth, but consider very simply a two outcome, and I will denote that gamble using the green color. One arm, two arm, probabilities being half, the wealth being W1, W2, then the corresponding expected value which should match UC, which is in the blue color, I am using the green color for the gamble. So, U of W would be equal to half into UW1 plus half into UW2. So, whatever the values of the wealth is given the utility function, these two values would exactly match. I will use the red color to symbol where this one UC and UW would exactly match. They has to match, and there would be some value of C which will make them equal. Now, extending that idea to the capital asset pricing model, which where we use different concept of optimization. So, few important points: investors have quadratic utility function, and this is important which I will mention, and share prices are log normally distributed. Here one important fact is, which I am marking in red, is quadratic utility function would mean that if the utility function is, I am only using U, is W minus half of A W square, or to extend it, that if you have an investment and you consider the return, and the return concept I am trying to utilize the green color. So, there are two returns, one is total return, one is rate of return small r. So, if small r is normally distributed with a mean mu r and variance of sigma r, then the wealth or the investment based on which the small r or the rate of return is being realized would be quadratic. That means, if r is normal, the utility function is quadratic, if the utility function is quadratic, r is normal. This would be true. Share prices are log normally distributed, and based on that, if you remember one of the examples where we plotted and did the optimization for, when we are discussing the introduction part, optimization of the either the return or minimization of the risk, maximizing the return or minimizing the risk for a portfolio considering of NSE stocks. So, there we consider the small r as log normally return, and we used, if you remember, again a different color being used in order to make things. So, r was calculated by Neperian log of P2 by P1. This P2 and P1 are the prices which are basically wealth, if you can understand. Price P2 is the closing price for day 2 and P1 is the closing price for day 1. Now, comparing the point which I just mentioned, normality and quadratic utility function being quadratic and rate of return being normal. So, comparison between mean variance, which is considering normal distribution with utility function, where we consider the utility function as given here, which I am underlying, is basically quadratic. So, this is the same form, W minus half of A W square. So, here A by 2 is considered as B. So, this is just a constant and we are trying to utilize that. Considering there are 3 assets and the assets are A, B, C, the prices are given. second column, third column price for B, fourth column price for C, and I use the total return. So, I could have also used small r, there is no, only the few formulas would change, but the concept remains the same. Just for information, I will write out here, if my wealth or investment, the word wealth investment I will be, for this example I will be using interchangeably. Consider capital R, which is total return, would be investment at time period 2 divided by investment at time period 1. That means, if I invest 100 today and I get back 110, then the capital value of R would be 110 by 100. If I invest 100 and if I get the value of 90, then capital R would be 90 by 100. Similarly, small r would be the difference of I 2 minus I 1 in the numerator divided by I 1. So, if I have 100 investment I 1, I get 110. So, in the numerator it will be 110 minus 100 divided by 100 will give me small r. So, this is the small r return distribution I am talking about, normality. So, R let us consider based on the fact that capital R variation would also be normal. So, consider we find out capital R. So, capital R would be what? The for A would be 110 by 100, which is 1.1, 115 by 110, 1.05, 120 minus 115, and so on and so forth. So, the values are found out. Similarly, for RB, which is for asset 3 as 2, it is 115 by 105 for B, and then it will be for 120 by 115, 125 by 120, and 130 by 125. So, this is for B. And for C, I have the values as 90 by 80, 95 by 90, 105 by 95, 130 by 105. I get the this second last column of capital R C, and the probabilities I consider as 1/5 for each of these outcomes. So, based on that, I find out the average return. So, average return for I am marking with orange on this a little bit darkish yellow color, R bar A, R bar B, R bar C. What is that? These returns capital R which I have calculated for A, add them up, divide by the total number of such instances. There are 4 instances, because prices are 5, but when I calculated capital R, it will be 4 in number. Similarly, for RB, again adding up the 4 returns for B divided by 4, for C it is adding up 4 returns for C divided by 4. So, the corresponding values are given here, 1.06, 1.05, 1.14. Similarly, I find out the standard deviation for A, B, C from the sample. This is the sample. So, given that standard deviation formula for the sample, given the mean value for the population is unknown, mean values are given from the sample as here 1.06, 1.05, 1.14. I find out the standard deviation. And just for information, the value of the variance given by population mean is known. We know that. So, this was done in DADM 1, the course which I have taught, or in any statistics books you can find. If the mean value, expected value of the population is known, which is mu, the best estimate for the variance is given as 1 by n summation of x I minus mu whole square, and I is equal to 1 to n, where n is the sample size. If I want to find out this is a different estimate, and why? Because the population mean is unknown, I replace the population mean with the sample mean. This is for the normal distribution, remember, because x bar n is the best estimate for the population mean, x bar n is the sample estimate. So, if we use any of these formulas, obviously the second one will be used, which I am just marking in a square box, because the population mean is unknown. So, based on that I find out, then I find out the weights. The weights are just simply the wealth. My apologies, wealth I find out just the sum of the wealths for each investment divided by the number of instance, because there are 5. So, these values come out to be 114, 119, 110. So, considering the time limitation for this lecture, I will continue this discussion further on in the next lecture. Sorry for that, but because we have been discussing many things. So, I will continue from the same slide and consider in the 16th lecture the ending of this problem. Thank you very much and have a nice day.